So I'm very happy to be here. I'm very happy to support Roberto and the center and this very exciting new endeavor and this exciting inauguration, or what to call this, of the center. So I'm Sven Karlsson. I'm an associate professor at ETU Compute. And as Roberto said, I'm going to talk a little bit about high-performance computing, because I'm a high-performance computing person. And I'm also going to talk quite a bit about how you can leverage high-performance computing in autonomous systems. But first, given that I'm a high-performance computing person, I need to talk a little bit about high-performance computing. So probably you're all aware that a lot of interesting things are happening with high-performance computing today. Some of it relates to autonomous systems, some things do not. But I'd like to highlight a few things that makes me very proud as high-performance computing researcher working in this field for many decades now, is that now we really see, and I feel also that the general public see the need for high-performance computing. We see the community come together working on different types of vaccines and different types of surveys and modeling of the old famous COVID-19 virus, trying to see if we can find any solutions. You may know that Fugaku, now the world's fastest supercomputer in the world, actually was put into commission early, 6 months early, and was exclusively used for COVID-19 research for many, many months for free in order to serve the society. And we also do a lot of work on EU level, where we're now starting to look into building a digital twin of the Earth for sustainability and environmental research. So a lot of exciting things with HPC, and I'd like also to highlight that ETU is involved in many of these things as well. So I hear many of you screaming, at least those of you that are close to a mic, that what's going on here? I thought this was about autonomous systems. So I would like to get to that point. So I'd like to point to a couple of things that I work together with various friends, colleagues, both at ETU and elsewhere. First, I would like to talk a little bit about some work that friends of mine at the university, Lucas, Patrick, Stefan, Kalle, Liang, have been working on, and I've been engaging on the sidelines here a little bit. So here is a table. If you look very carefully, it's going to be evident in a moment. You actually see a small drone. So let me run this video. I hope you can all see it well. At least I see that you can see it. You see the drone taking off, flying about. What's interesting here, and I like to point to that this drone knows nothing about the room. It knows that it should take off. It knows that it should fly about and come back to where it took off from. But it knows nothing about the room. It knows nothing about surroundings. And it's currently, as it's flying around, mapping the environment and trying to understand where it is and trying to understand where it can fly. And it does this, if you wish, in real time. And soon you will see this drone identifying the landing spot and going down for landing, and pretty soon it will land and turn itself off. So this is done entirely without any kind of assist. And this requires a lot of compute resources. I think everyone will agree that this is indeed high-performance computing. So let me give you a couple of more examples from what's going on here. So you may ask yourself, okay, I get it that this drone needs high-performance computing for this particular task, but what else is there? I mean, I would argue that high-performance computing is needed pretty much everywhere that we have autonomous systems, and I think the prior talk very elegantly described some of these scenarios where high-performance computing is indeed necessary and also supporting the well-being of many, many, many people who are being challenged. So I would again say that all autonomous systems need HPC into some capacity. I see HPC as a fundamental enabler for many technologies. Further, HPC technologies themselves are used across the technology stack. So why is this so important? So let's just go back 2 years. By technology, these are the Stone Ages, pretty much, right? So in 2018, a self-driving car generated about 6 gigabytes of data every 30 seconds. And it used about 2.5 kilowatts of power just to do computation. A lot of things have happened since then. And things are better now. We can have probably self-driving cars at lower compute power than this. But still, we have a massive influx of data, and we need to deal with it somehow, right? Another further reality check before we go into more details here. So coming back to the drone I showed you, if we are to do this on the drone, I must confess that we cheated a little bit. Sorry for that, we did. So if you look at the actual compute needed here, it needed somewhere in between 10 to 50 watt of computing power. This is somewhat equivalent to a low-grade desktop computer, certainly more than a laptop. And we need actually, in order for this to work well on an actual drone, to get to about 100 milliwatts. And this is something that my colleagues at Lund University and myself are looking into. I can't at this point go into too many details because we have a couple of patents pending, and there is also some exploitation plan, but we are shooting for that round number there. And I think we all agree that this is where we need to get to in order to make autonomous systems really viable. We can't have the control hardware, the control systems essentially being luggable if we want to build a small drone that flies around. That does not work, right? We need to have working autonomous systems that are able to do this, solve their tasks at a reasonable level of size and a reasonable level of functionality. All right, so let me go through a couple of other examples and some arguments for why we need HPC and high-performance computing technologies. I like to argue saying that we can't do all things in the cloud. We need to do a lot of things at the edge. So coming back to the self-driving car example, 6 gigabytes of data sent every 30 minutes is a huge challenge. Sorry, every 30 seconds is a huge challenge, even for the most advanced communication systems. Even for 5G, this is a challenge. So communication, overhead communication cost, even communication load on system would be excessive unless we actually do autonomy at the edge, that is at the actual vehicles moving about. Another thing is privacy. So I think we all agree that we would not like to have our personal pictures, our personal information to be shared with everyone. But this is a clear and present danger if we do processing in the cloud. I think we all would be a lot more comfortable with systems processing locally and thus sharing the very basic detail, the very basic information needed in order to solve the tasks, right? Essentially, where am I, rather than how does my surrounding look like. Another thing is latency. Self-driving cars is one example, the drone is another example. We can't really depend on a cloud to react, or even perhaps not being able to react if you're flying about and perhaps crashing to something. So communication, privacy, and latency demands require us to do computation very, very close to the sensors, and in this case, at the autonomous vehicle. So if you look at what's happening here and looking at what we need to do, the tasks at hand, the data involved, the computation involved, and so forth, we see that HPC workloads and edge compute for autonomous systems, they are quite similar compute density. So we need to think of the embedded systems as sort of small flying or moving high performance systems, because really it's that density of compute we're looking at. The good thing is that we can leverage HPC technologies here, and we do that a lot. One example is the drone I showed you. I'd like to go further and point to some additional examples. I think it's difficult to ignore in the last couple of years how important machine learning and AI have become. So, for example, OpenAI has noted and has a very, very nice survey showing that AI training runs double in compute requirements every 3.4 months. This is a quite aggressive exponential growth. And in fact, it's projected that we will see more than 20% of all energy production in the world going into compute, a large portion of that going into AI. And I'd like here to bring up a couple of things. When this discussion is brought up, I hear a lot of comments about, well, okay, this is about getting more GPUs or getting more hardware or whatnot. I would argue here and give some examples that this is not really true. Hardware and GPUs are not quite often not the bottleneck. And in fact, we need to leverage HPC technologies. So this is an example from industry. And a company where I had the pleasure to work at for a period of my life, where I got the information that, well, we have some nice GPUs, but we only running them at 13%. We can't get them higher, so they're useless. We can't use them for everything, right? I mean, why are we even bothered with GPUs? And I felt, okay, no, this is not quite right. So I convinced I convinced my colleagues that I was allowed to look into this and also work with a couple of good friends and colleagues of this. So we did some analysis of this. So the first thing we did, we looked into the system and figured out that, well, you know, one bottleneck, the first bottleneck we saw was not GPUs, but actually file system bottleneck. We had the file system performance was not good enough. This was a state-of-the-art data center file systems, but it was several orders of magnitude slower than the GPUs. So we implemented a quick and dirty but HPC level storage stack instead, and we got the performance of the GPUs radically up, however not at 100%. So we in fact to the draw board, look into the system again, and saw that, well, okay, the GPUs are always waiting for data for the CPUs. And it was that the system was not balanced well enough. We didn't have enough CPUs with respect to GPUs. So we rebalanced systems, having more CPUs working on the system in tandem with GPUs, and we got 100% GPU utilization. This is a quick example of how leveraging HPC technologies and experiences in the AI domain can give you a substantial improvement of performance. So we got here 8x by essentially throwing no money at the problem, but rather tuning the system, leveraging experience well known from the HPC crowd. And this has been seen by several people also since a couple of months ago. I also worked with Tobias Jensen at Aalborg University, where they had a similar experience, and we saw that it was consistent with my experience from that company. And we also see a lot of players invested in HPC hardware to solve AI problem. One example is here to the right-hand corner from an installation where you essentially use HPC systems to solve AI tasks at great efficiency. So another example we see is with digital twins. Again, the prior talk talked about this as well. This is an example of a self-driving car. I was not involved in this. This is actually stock footage from Wikipedia. under Creative Commons license, so it's free to be used. But I've worked with systems looking very much the same. So you fill a car up with sensors, here sensors on the roof, but also compute everywhere. And then you drive around that car, having the compute part of the car, checking what the driver is doing and learning from the driver, and running several different algorithms in parallel in order to figure out how to drive the car. This requires you to address the problem of autonomy from a HPC perspective in order to be able to actually have the compute power required in the car and having it running on the road without having the car turning into a truck. So these are just some examples. I can see that the clock is ticking, and that's actually quite good because I'm getting to the summary slide. So again, I would like to argue and vigorously that all autonomous systems need HPC, that HPC is a fundamental enabler in many domains, including autonomy. And HPC technologies, as I've shown, can be used across the technology stacks in many different application domains. And actually by doing so, you can enable new possibilities in system design and allow for new and innovative systems to be developed. And now, given that I'm here and have the stream, I thought also I would provide you with some important information saying that DTU is taking a proactive stance on actually leveraging HPC and HPC in many different domains. So we have a new HPC laboratory that is gaining traction. It focuses on research on HPC technology. We are open to engage with everyone, including, and I hope that we will do that very fruitfully with the center. But we are also open to working with any of you solving your problems. And we are also open and working across different universities. We have several persons working with us across Denmark. And we truly believe in open, inclusive, and transparent processes. We believe that this is a very exciting area to work in, and many can benefit from our expertise and technologies, but also to work with us. So I hope you all are interested in hearing more about this. I'm not going to steal the thunder in any way, because of course we're celebrating the opening of a new center here, not about me talking about weird and nerdy things called HPC. But if you do interested in talking more about this with me, you have my contact information there. And I believe there is time for questions. In the meantime, you can enjoy looking at the drone flying again. Thank you so much.
So I will thank you very much, Sven, for the very interesting presentation. I will bring you back, if you can. Yeah, well, we can see you, so no worries. There is room for question, please. Lazarus. Yeah.
As I'm sure it's working. Thank you, Sven, for a great talk. Very inspiring. I would like to have your opinion. So apparently there was a period some years ago where the clusters were the way to perform serious computing, and then it sounded outdated some years later, and everybody had the computing capacity at home. And now deep learning came, and we're all looking into high-performance clusters once again. But then people are also a little bit objecting. You also mentioned doing computation on the edge. Why should I share my data with DTU or whoever owns this cluster? So right now, I think the state of the art, at least where I work in, which is robotics, is that edge computing is good for inference, but all the training takes place somewhere else. So do you see this trend changing and doing also training on the edge, or is this something we should leave to the clusters?
Thank you. This is a very, very good question. And I fully share your viewpoint here that we see a shift of computing power going back and forth between different entities. So I think for the foreseeable future, and the foreseeable future here probably is a couple of months, unfortunately. Things are happening very fast in the AI machine learning domain. I think we see training activities going on in clusters, at least in large-scale installations. I also hear and see a lot of innovation happening in training algorithms, and I'd like to point to last year's Turing Award awardees, who we all know was the founder of the modern machine learning AI revolution. They pointed very clearly to that we need to see more training algorithms that actually can scale all the way to the edge. And I think this will happen. I'm not sure when. I've seen some people looking into this direction. I'm not sure I'm all that convinced that they're having the right approach, but it will happen. In the meantime, we need to do this on clusters, I believe. The other thing I would like to point to is that we should not see this as completely separate systems. So I'm a firm believer in something I tend to call, and many with me call, the computing continuum, where we're looking at where does it make sense to place compute. So there are certain elements of a system that make sense to put on the edge. There are certain elements that make sense to be put in the cloud or in intermediary nodes between the edge and the cloud. And then we have elements that are in need of the highly specialized, compute-intensely aspects of high-performance computing. But that said, I think the main getaway here is that HPC technologies can benefit all of these technologies, including the cloud computing. So even though HPC in the past probably have seen as a very specialized technology, we see now that exactly the same technologies are applied in the cloud for AI training, but also at the edge in order to handle the sensor input, doing SLAM, doing sensor fusion, and so forth. Thank you for your question. Sorry for a very long answer, but it was a good question that deserved a in-depth answer. Thank you.